as we start in with 2.5, this is finding slope and the y-intercept of a line and graphing it. So we're going to start talking about what it looks like in words. So in words, basically a linear equation of the form y equals mx plus b. This is slope-intercept form. The m is equal to slope, and the b is equal to y-intercept. That's why we call it slope-intercept form, because we have the m and the b. Now the actual formula, yes, is y equals mx plus b. And with that being said, we have some key components. This is, of course, oops, let's change the color here. This is my slope, and this is my y-intercept. With that also, we have the input, and we have the output. Now, if I put this into words, basically, for word problems, we're basically saying that y is like your total, equals your rate times the number of plus the start. Because the y-intercept is your starting amount. Like when x is 0, it'll be the y value. Now, the graph, when I go to graph something like this, and this is my x, this is my y. When I go to graph, let me give you an example. Let's do, I don't know, y equals 1/3 x plus 1, for instance. Well, to graph this, what we're going to do is we're going to plot the y-intercept. So we're going to, here's the y-intercept, we're going to plot on y-axis. This is where we start, aka start down here. So we're going to start at 1 and put a dot. Now from that point, we're going to use slope. So we're going to do slope from that point. This means up 1, right 3. So we're going to go up 1, 1, 2, 3, and put a dot. And I make you do 3 points just because any 2 points you can make a straight line. So we're going to do another one. We're going to go up 1 more, and then over 1, 2, 3, and make another pretty line. So make another dot, and then oops, make a pretty line. That's kind of ugly, but it's pretty. So with that being said, our concept 1, so that's the base of what we're doing today. So now we're going to look at the identifying the slope and the y-intercept of a line given an equation. So if I give the equation, the first thing I would suggest you do is make sure it's in slope-intercept form. So y equals mx plus b, because then we can just look at the number in front of the x, or the coefficient of the x, and then the constant. Okay, so we're looking at the coefficient of the x and the constant. So here the coefficient of x is 5, so my slope is 5, or you could write it as 5 over 1. And then my y-intercept is -3, or you could write it as 0, -3. Number 2 here, or b. B, let's go with a purple. This is a y equals, so I'm going to tell you that it's going to cross the y-axis at -2. And I'm a very visual person, so I'd probably go like this, and I would say y-x crosses at -2, so -2, and I would say it looks like that. So with that being said, my slope is 0 because it's a flat line, and my y-intercept is going to be -2 because it crosses the y-axis at -2. Or I could write this as 0, -2. The next one, I'm going to put a little line down the middle here. All right, the next one needs some rearranging because it's not solved for y. So I want y by itself. So to get y by itself, I'm going to move the x value to the other side of the equal sign. So minus the 3x, minus the 3x. And I end up with -3y equals -3x plus 12. And then we need to divide each of those by the coefficient of y, because we need to divide by -3. So I end up with y equals 1x minus 4. So my slope is 1, or you could write it as 1 over 1. And my y-intercept is -4, which we could write as 0, -4. For letter C, let's go ahead and do some steps for C. For letter C, basically what we did is the first thing is we rearranged. So to rearrange. And we did A, the first thing we did is move x's to other side. And then we, B, divided by coefficient of y. All right, D. D is similar to B up here in that it's got just one variable. So one variable means it's going to crosses, in this case, x-axis at 5. Again, I'm very visual, so I'd probably like this, and I'd say 1, 2, 3, 4, 5. Crosses it, and this is x-axis, this is the y-axis. So I'm looking at this. This is going to be my slope is undefined. It's a vertical line, and my y-intercept, well, there is none. There's no y-intercept. And the last one, we have to go back over here for C, and I'm going to say E. So we need to rearrange by moving the x's to the other side. So I'm going to go minus an x, minus an x. And if you would like to put that 1 there, you can. So minus 1x. So I end up with 4y equals -1x plus 6. I just pop that right in there because that's the format that I like. If you want to put it at the end, that's fine. You just know the slope is the coefficient of x. So we're going to divide both sides, everything, by that 4. And when I do that, I end up with y equals -1/4 x plus 6/4, which is 1.5. You could also write this as y equals -1/4 x plus 1.5 if you want to give that part as a decimal. Please keep your slope as a fraction, though. So my slope equals -1/4, which means down 1 over 4. My y-intercept is 1.5. That's, or you could say 0, 1.5. So then we have some steps for graphing. So we're going to graph an equation using slope-intercept form. Well, first thing we have to do, kind of like what I did up here, we have to make sure it's in slope-intercept form. So step 1, arrange to y equals mx plus b. And if you need help on how to do that, remember that steps are right there. After it's there, I need you to identify the slope and b. So the slope and y-intercept. Then I need you to plot the y-intercept on the y-axis. Now this next step is like the biggie. Okay, so this is the next point. After you've plotted that y-axis, then from that point, so from that point, use slope. Rise, up or down, and then across. So up is positive, down is negative, and then to the positive. So rise over run. And repeat the point or the slope for another point. Similar to what I modeled at the very, very beginning. But we're going to try a few more of those down here. So down here I have y equals 3x minus 2. And I have y equals -x plus 3. So pause me and try them on your own. Identifying the slope, the y-intercept, So pause me. All right, so my slope here is 3, or I could say it is 3 over 1. And my y-intercept is -2, or I could write it as 0, -2. So 0, -2 is going to be 0 across, down 2, put a dot. From that point, I'm going to go up 3, 1, 2, 3 over 1. Up 1, 2, 3 over 1. And make a pretty line. The next one, oops, I left my line here. The next one, my slope is -1, because this is like a -1 right here. Or I could write that as -1 over 1, so it'll be down 1, right 1. And my y-intercept is 3, or I could write it as 0, 3. So 0, 3 is right here. Oops, 1, 2, 3, right here. From that point, I'm going to go down 1 over 1, down 1 over 1, and make a pretty line. Notice I already have a line there. But I should put my arrows on it. There we go. Again, if I'm going too fast, you can always pause me and catch up and then push play and see how you did. So always try these on your own. So try them and then come back to me. All right, this one's going to be crosses y-axis at -5. So I know at -5, 1, 2, 3, 4, 5. It's a horizontal line. My slope is 0. My y-intercept is -5. The next one crosses x-axis at 7. So here's 1, 2, 3, 4, 5, 6, 7. Try to make that straight for you. So it's a vertical line. My slope is undefined because it's up straight up and down, undefined. And it never touches the y-axis, so there is none. Okay, number 8. This is the last one on this page. I need you to do all the steps. We have to do from the very beginning of rearrange, and then identify the slope, the y-intercept, plot the y-intercept, and use slope from that point. So rearrange first of all. Try it on your own and then come back and check it with me. -6x minus 6x, I end up with -3y equals -6x minus 9. Divide by -3 on all terms, so I end up with y equals negative and negative is a positive. 6 divided by 3 is 2x. Negative is a positive. 9 divided by 3 is +3. So my slope is 2. My y-intercept is 3. So up 3, 1, 2, 3, put a dot. And then I'm going to go up 2 over 1. Up 2 over 1. So it's 2 over 1. And this could be 0, 3, if you'd like that. So this would be up 2, right 1. And make a pretty line. All right, one more like that. So try it again. Try this one on your own, and then come back to me and see how you do. I'm going to add 2x to both sides. -5y equals 2x minus 10. Divide by -5 on all terms. Y is equal to -2/5 x plus 2. Now, this negative, okay, so I have a -2/5. That could, oops, 2/5. That could be -2 over 5, or it can be 2 over -5. Either one is the same thing. It's going to get the same thing, but it's one negative, not two negatives. It is not -2 over -5. Not, okay? So my slope here is -2. I usually attach it to the top, which would be down to right 5. And my y-intercept is 2 or 0, 2. So 0, 2 is right here. From that point, I would go down 2 over 5, 1, 2, 3, 4, 5. And I could keep going down 2 over 5. However, if I chose to go in the other direction, like I told you over here, if I said it was a 2 over negative 5, I could have said up to back 5. So, oops. So if I did that, it would look like from the starting point is here, I would go up to back 1, 2, 3, 4, 5. Notice it's still in line with my dots, so it still works, okay? And the last one that we have on here is talking about parallel lines. Now, parallel lines have to have a couple, first of all, when you talk about parallel lines, never touch, right? So parallel lines never touch, meaning they have no solution. Okay, so when I talk about two lines we have intersecting, that would be one solution. When they're parallel, they never touch, so there's no solution. Or I could have two lines that actually overlap each other, and this would be the same line, so there are infinitely many solutions. Okay, so infinitely many solutions. Let's talk a little bit about each one of these. These are called intersecting. These are parallel. And these are the same. So when I'm looking at this, they have to have different slopes to intersect. So they must have different slopes. Okay. Parallel and the same line. Well, parallel and the same line have to be slanting at the same. So they have to have the same slope. And the same slope. Okay, what makes them different from one another is their y-intercept. So this one has to have, if it's the same thing, it's going to have the same slope and the same y-intercept. However, if I'm parallel, I have to have a difference. So like they have to have different y-intercepts. So different. Okay, they have to have different y-intercepts. So as I'm looking at my problems up here, they all look kind of parallel. However, we can calculate and find out which ones are actually parallel. So I'm going to call this one A in green. So A, we're going to find its slope and its y-intercept. So its y-intercept is, here's the origin, right? We're going to go down to 0, -3. So B is -3. The slope is going to go rise over run. I'm just going to count down 1, 2, 3 over 1, 2, 3, 4. So the equation would be y equals -3/4 x minus 3. I'm going to try B. We're going to put it in blue, my slope here and my y-intercept here. So B, my y-intercept, if I look at, here's the x-axis, here's the y-axis, it's going to be right here, which is at 1. And my slope, I'm going to make a right triangle to get down to the next dot that's plotted. And I went down 1, 2, 3, 4. So down 4 over 1, 2, 3, 4, 5, 6. Now that reduces to -2 over 3. So y equals -2/3. Ooh, that's ugly, 3. -2/3 x plus 1. And then the last one, let's do pink here, C. So if this is C, my y-intercept, here's my x, so up 1, 2, 3, so up 3 or 0, 3 is up 3. So my slope and my y-intercept is 3. My slope then is going to go down and over. So we're going down 2 over 1, 2, 3. So down 2 over 3. Y equals -2/3 x plus 3. So now I can compare them, and I want to know which ones are actually parallel. Parallel means they have the same slope and a different y-intercept. So 3/4 negative 2/3, and negative 2/3. So I'm going to tell you that B and C are parallel because same slope, different y-intercept. And I'm going to put a box around it. There you go. Now, don't forget you're going to go to Schoology. Actually, you can go through Summit. So through Summit, you're going to do checkpoint number 10. There are 2 links in Schoology to practice what we just went over with slope-intercept form. And then once you're finished with that, then you can request feedback.